So today let's talk about mathematics. Now, before you all run away, just hear the introduction first. And some people, I noticed, don't like mathematics. And probably that's the way they have learned it or not learned it in school. And with mathematics, it's a system of thinking. It's a very systematic language that's used in science. Yeah. So it's the language of science, of natural sciences at least. Yeah. Language of science. And why would you want to use such a complicated system to talk scientifically? It's because of its precision. It brings precision into science. Precision. It brings repeatable results. You find something, describe it mathematically, and so it makes it repeatable. And that is what distinguishes scientific knowledge from other areas of knowledge. You can repeat it, you can experiment, everybody else will find the same results. Yeah. So to describe your results in that precise manner and in a repeatable manner, you need a language. And that's the language of mathematics. Yeah? So you can describe it numerically, what happens. Yeah? You do an experiment. Yeah? Let's say you throw a little ball. Yeah? And then this ball will go on a certain track like that and will arrive there. Now, everybody can see that, and everybody knew that before Galileo Galilei. But then Galilei actually did experiments and checked out when is the ball here, when is the ball there, when it's there, when it's there, and when it's arriving there. Now, the ball is going to fly like that. And in these times, at these times, they wanted to see how cannon bombs are flying. Yeah, and they wanted to know whether they hit the target. Yeah? So that was actually the intention, to calculate an exact distance here. Yeah. So how far will that go, and how does it depend on that angle? You have that first angle here. How does it depend on that angle and the speed you throw it off and all that? Now all that today is completely perfectly understood with mathematics. Yeah, so you need to know some system of how to calculate that, and mathematics provides that system. So I'm showing you the advantages of mathematics here. Yeah. So the advantages. Yeah, it's not only precision, repeatability, advantages and in here. It's you can pre-calculate the outcome of an experiment. Yeah. That's so before you start throwing balls, around, you want to know where does it arrive, at what time does it arrive, yeah? And you can calculate that before. Yeah? So that's why you need mathematics. Yeah? So you calculate in advance. Yeah? Calculate in advance. The outcome of your experiment. Of an experiment. Yeah, now that's a physics experiment, and then you do machines and all sorts of things, and then you don't call it experiment anymore, you call it technology. Yeah. So, and it doesn't have to be war technology here. It's a bit unfortunate that they used it for so much war technology, but all other use of technology also depends on mathematics. Yeah. So technology through mathematics gets these qualities of what we had here, of precision, of repeatability. Yeah. So technology gets precise, repeatable. Precise, of course, should be spelled precisely. Repeatable. And so these are qualities that come from mathematics into technology, yeah, into engineering, yeah. So engineering. And that's what makes our comfortable life, yeah. You switch on a button, yeah, and the light goes on. It's precise, it's repeatable. As long as the light works, so long this is a precise, repeatable action. Yeah. And that works not due to good luck, but it works due to mathematics. Yeah, because all those components involved are done with a mathematical precision. Yeah, and so a lot of our modern world and the comforts we enjoy in all areas, in computing, in communications, in media, all that is based in the core. It's based on mathematics. Yeah? So for many people who don't understand it, it's like magic. Yeah, but it's not. Yeah, so it's yeah technology is not magic. Yeah. Not for everybody. Yeah. It's not magic for those who understand mathematics. Yeah. And also mathematics is not magic. Yeah. Who understand mathematics. Yeah, because with mathematics you can understand technologies. Yeah, because mathematics is at the core of technologies. Yeah, the core of technologies. If you ever want to get your knowledge of modern technology out of the realm of pure magic, you have to enter through the door of mathematics. Yeah, the core of technology. Yeah, and you enter through the door of mathematics. So I hope that gives you some motivation, yeah, to learn a bit mathematics through the door of math. Yeah. Now, there's another reason why you want to learn mathematics. Yeah, there's a what I think even deeper motivation, yeah, to learn mathematics. Motivation to learn mathematics. To learn mathematics. And what is that? Mathematics is a way to explore your mind. It's a way to explore your mind. Your mind. Why is that? It gives you, it may be only an aspect of your mind, but it's important to have that aspect enlivened. And it gives you a way of abstract thinking. It gives you tools for abstract thinking. Yeah? And when you are trained with mathematics, you can easier think in an abstract way. Yeah? So it makes it easier. And why would you want to think abstractly? Because by thinking in an abstract way, you can cover a larger territory. Yeah, in an abstract way, you can understand huge areas of knowledge rather than only little details. Yeah, so it's easier to understand great concepts if your mind is trained with mathematics. Great concepts, yeah. And that includes infinity. Infinity is very important in mathematics, and infinity is very important to evolve your consciousness. Yeah. So evolution of your consciousness Yeah. That infinity, that leads to this. Understanding infinity, grasping infinity, comparing it to the finite. This is the real great possibility with mathematics. Yeah. So probably when you learned mathematics in school, you haven't heard of these possibilities. Yeah, and so you started probably mathematics not very inspired. But it's not too difficult. We won't do it like in school where you miss something and then you never catch up. Yeah. So no, we'll do it in these little video segments, and so you can always view some again. Yeah. So video segments. We'll do about 15 minutes each. Yeah. And if you haven't understood one, then go back to it, view again, yeah, and then view others. And I'll give references to previous lessons so you can view them again. Yeah, view again, and make sure for yourself that you really grasp the essence of each one. Yeah, and then we can build up on that. And that's the mathematical system. Yeah, you build it up. So you have like some logic. Yeah, you understand one bit, then the other bit, then another bit. Yeah, and then from this one you may require this to get to a third. Yeah, so say A, B, C, D, and then you may need both of those to understand something else. Yeah. So each one of these circles is like one of the lessons. Yeah. And then it builds up. Yeah. So and I'll give you some reference. You know, if you need something here, if you need to understand something here or there, I'll tell you that. And then it's not too complicated. Yeah. So it shouldn't be like shouldn't be unfortunate like many had it in school where they missed out something. Say if you miss this lesson, yeah, then you can never catch up on all those other things, yeah, of course. Yeah. But we'll structure it like that, that if you miss this thing, you just go back and learn this, and then you'll catch all this that builds up on it. Yeah. So that is part of mathematical thinking. The parts, they build up on other parts, yeah, and you have to have that complete sequence of events. It has to be all clear. Yeah. But once you know this system, you can it will be fairly easy here. So you don't need to go through stressful experiences that you had before, and I hope this gives you enough of a motivation to look more of those mathematics course segments. Okay, so hope to see you again in some future video.